Hello, hello. Good afternoon. Welcome to Ansible Toronto Meetup, August 2020 edition. My name is Aaron. I'll be your host today, and we've got a good set of two presenters going to be talking about things related to Ansible today. And without further ado, let's continue to look at what's going on. So for August 2020, hello regulars and new people. If you've previously been at our in-person meetups, but never the virtual online ones, welcome back. And we're going to do all of our QA through the YouTube Live, the chat that you'll see on the right if you're in the YouTube Live. And feel free to drop a link and get in touch with us after the event via any kind of messaging, tweets, LinkedIn, Slack, wherever you happen to be in touch with us. A big thanks to Arctiq, Red Hat, StreamYard, and YouTube, without which we couldn't get this done. And thanks to the speakers for stepping up today as well. So a few notables. I'd like to go through a quick update on stuff that's going on with Ansible and Tower or AWX, whichever you happen to use, before we jump into the talks. But if you look at what's going on with 2.9.10 through 2.9.12, we covered everything from 2.9.9 on the last meetup, which I do believe is still on our YouTube channel. Mainly it's been bug fixes and security fixes. Another big thing that's in effect right now is Ansible collections. And you might start to see that when you're trying to use things like suites of Ansible roles and modules for particular clouds. And in those cases, you get, for example, an entire public cloud of Ansible modules specific to that public cloud, that's set inside one collection that you have to download and include as part of your next Ansible run that involves using that particular cloud. And this applies for many other different things. Even with network devices, you need specific Ansible collections of modules now to attack specific network devices. So one of the specific ones I called out here is the Ansible Galaxy collection install. Now, if you previously didn't use Ansible Galaxy, you're definitely going to start using it now quite a bit more because you have to pull in collections on a regular basis. Other interesting stuff that's happening, Tower 3.7 to 3.7.2 has had a few small changes. A number of people I know are going to be happy to see Python 3.6 is now the minimum requirement for Tower CLI. A number of limits were removed, allowing a staggering 2 billion total events possible for Tower to store in a current queue. And that's a pretty high number. You'd have to have a pretty beefy cluster of Tower to make that work. As of 3.7.1, there's a big focus on collections, I already mentioned. And a few satellite foreman things are included and called out in the release notes. So if you happen to use satellite or foreman, get a look at what has changed. As of 3.7.2, we've sort of deprecated primary Galaxy username and password in lieu of tokens. That doesn't mean it's completely removed to use those variables, but it's going away, so plan to account for that. And one more piece is local caching for downloaded roles and collections in 3.7.2. Those are just some of the notables. There's a number of other release changes that you might want to go look at when you start working on either platforms. So for today, we have two talks, and then we can do any kind of Q&A you like, which we'll pull in from the chat. So if you have any questions, be it during or after the talks, please throw them in the YouTube chat, and I'll bring them up with the speakers. So I'm going to bring them into the stream, and we can say hello. So we've got Tim and Greg. Hi, guys. Say hello.
Hey, Aaron. Hey, guys.
Hey, guys.
So what we'll do is we'll start with Greg, and Tim can take a short break. And Greg, it looks like you're going to be talking about making Ansible make Slack talk.
Absolutely, so, yes.
Excellent, very good. I'm going to bring up you, and Tim, we'll see you in a bit.
Thank you, Aaron. So yeah, could you please bring my screen up? Awesome. Okay. Mm-hmm. So just maybe I will start with one word about myself. So I've been in Toronto for 6 years, and in Toronto I've field position from developers to director of engineering, and this is where I started using Ansible as a developer for file exchange, and so something that was really for me the introduction to infrastructure as code. Before that, I was using more bash script and those kind of things. And today I'm working for Arctiq, and we are focusing more on DevOps, Kubernetes, and microservices. So what I really like to do is leveraging all the tech and especially communication tools and automation to facilitate the communication across teams. I think if you automate things, it's really removing some human factors and some and people can get can be kept in the loop for every kind of changes. So this is why I will show you how to use an Ansible callback plugin to improve the integration of Ansible with Slack, and at the product level more you can communicate on the DevOps and infrastructure activities to people who are not necessarily familiar with the tools like Ansible Tower or AWX. So yes, the callback plugin for Slack, I'm aware that there is a community version existing, but it seems that it has not been maintained in a while, so it's a way to revisit it and make it work. So I will show you the end-to-end deployment for this thing. So one word on the plugin, on the tech behind the callback plugin. So it's an easy way to extend Ansible and integrate some custom codes at different phases of the playbook run. So as you know, it's Python based. Ansible is Python based, and so adding those hooks is as simple as just extending a class and overriding some methods. And some use case we could use this plugin for. So for example, if you have multiple team in your organization, like a QA team who is running on their own environment, or the dev team as a dev server, but you want to tell them exactly when something is happening, you could use this Slack plugin and post them a notification every time something is happening. Also, if you are the DevOps manager, you can also keep tabs on who is running what plugin from which machine, and keeping an eye on execution time and errors and those kind of patterns that you can see. Overall, I think maximizing the number of eyeballs you have on any system really improve the reliability and stability, so that's something that should be encouraged. Another example that could be interesting, Grafana, for example, if you use Grafana to monitor your metrics, you could automatically happen a marker or an annotation in the timeline whenever a relevant playbook is run. So you can see if you notice a change of performance, you can easily trace back to what run has triggered it. So now I will show you, so easily, just quickly, the pros and cons of this solution. So the cons is I would have preferred to be able to use the official Slack plugin, but it's not available, like I said. And the stats we will be able to report on are aggregated and kind of limited. So if so this integration can show the number of successfully run modules, failed, skips, those kind of things, but not much more beyond that. On the plus side, like I said, it's Python, so kind of easy to understand. You can understand the code. You can also tweak it and tune it to make to translate maybe, or make a better use of the raw information. So now let's see exactly what this translates to in reality. So here you will see this repository. So for this example, I will be using Vagrant to spin up 2 boxes. A good box here that will be running the good playbook, and a bad box that will be running a bad playbook. So the good playbook, quickly, it's just a hello world, changing the text, the message of the day. And I'm also adding a skipped instruction to see how this reflects in the run summary. The bad playbook here is just another hello world and failed module to demonstrate the result there. So now to install that, everything starts here with the Ansible configuration. So all the callback plugins will be found under this folder. And the plugin itself is here. So what I will do is I will start integrating a Slack webhook, and during the run, I will walk you through the code here. So let's go to our Slack channel. In this Slack channel, I will add a webhook. So the webhooks are apps that you can install just by clicking this button here. So here I will have to select the channel where I want to post my notifications. So I will create a new channel. Tap notifications. Some weird reason that didn't work. Try it again. Okay, not a big deal. I will create the channel manually here. Oh, interesting. All the channels have been created here. There is something funny happening with and I'm gonna add an incoming webhook. So very important. This webhook URL will be have to set up in an environment variable. Here, I can change the name. And I can change also an icon here. So in this terminal, I will export my webhook URL. And I'm gonna launch the Vagrant run. So while this is running, I can show you quickly the code. So very important for this code, I'm using the Slack webhook module from Slack, time and daytime to report on the execution time and the starting date. Socket here is interesting one. It's more for getting the host name of the machine I'm running my playbook from, and the callback base, which is the base class that I will inherit and override. Okay, so I see the run. It's completed. And I think my box were still up from last time, so I'm gonna destroy them and recreate them. So here in this callback module, I'm sending up, I'm initializing with the username of whoever is running this Ansible. The host name is from this socket module. The playbook name is taken from the execution path of this Ansible command that I'm running through the Vagrant file. And the starting time has a timestamp to compute the duration, and the start date time for a human readable date. So now my VM has been destroyed. I will rerun the Vagrant hub. So this playbook on stat is the function I decided to override for that one. So the playbook on stat is called at the end of the run, and this is where you will get all the stats, the final stats. So at the end of Ansible run, you have this line that shows you the number of module executed, okay, failed, skipped, and so on. So this is really what would be populated here. The first thing is I'm using two different colors if the playbook is running or failing based on the existence or not of the failure dictionary. Execution time, so that's when the stat stage is hit versus minus the start time. This URL is coming from our environment variable. And here some formatting. So the Slack module takes an array of fields, so you can separate each piece of information with a title and a value here. And the second part here is in the results, I am selecting all those keys, the O key, change, unreachable, failure, skipped, rescued, and ignored, and looping through that, making sure that we have a corresponding key. If we do have a key, just displaying the title and the value. And at the end, just the generic information from Slack, so the title of the post, the recap, and all the fields we've defined before. And finally, just posting to Slack. So the run, my VM run is still running. I don't know, it's taking a bit of time. So you can see now the good box is running the provisioner, running the playbook. And you have the discovery phase. Then the modules, the hello world, the MOTD change here, and the first run is done. So now you can't see on this screen, but I received a notification popping up on my screen. I can show you that on the Slack channel. Yes. And here you see the result with the icon we've selected with a good playbook, and you can see how many modules the playbook went through. One has changed, so that's changing our message of the day. One has been skipped, so I can show you. So I went very quickly on that one. So the skipped is so this skipped instruction. So I use the say module. So I don't know if you're familiar with that, but that's an extremely annoying module that says out loud the message here. So it's no longer relevant with the COVID and people working from home, but otherwise a good way to annoy your coworkers. And so I'm skipping it because the condition here I've set up when equals false. So now it's running the second VM, the bad box with the bad playbook. So while this is running, I will show you. I'll show you a bit more things. So if you want to see all the hooks you can use to trigger your custom code, you can go to this init.py, which defines the base class that we are overriding. So the playbook on stats is what I've been running, but you could also override the on task start or the runner item. So item per item, as soon as a condition is met, you could notify someone or update some stats or those kind of things. And I just received my notification on my other screen, and here you can see the bad playbook. So with my username, the host name that was coming from the socket library, name of the playbook, the start time, execution time, and the failure here. So yeah, so that's it for my demo. So if you feel the need of having those kind of integrations, if you want to push it further, I've seen that in the Ansible GitHub, there's a workshop to demo the chat ops, so how to do the same thing but both way trigger, also trigger actions. And the source code for this demo will be available on the Arctiq team GitHub repository under community events. I will push that just after this meetup.
Awesome, Greg. Very good stuff. We were talking about this beforehand, you and I, but how customizable is that output that lands in the Slack message?
So yeah, the nice thing is you can customize. So here all the limitations are coming from the Slack module, right? Slack has a very specific schema. You can define those fields as field values in a dictionary. But Slack is just one way of doing it. You can imagine just carving a different message, maybe a full MD report, and post it in the channel. There's a lot of different ways of doing that. So here I was trying to find a compromise between something that packs a lot of information and still sleek and nice looking, but you can absolutely go crazy with that. There's no sky is the limit.
Yeah, that's good. That's really good. All right, I'm going to hold back the other questions for Q&A at the end and let people absorb. That was really good. Thanks. And
Thank you, Aaron.
I'm going to move on to what we have here. So we're finished with Greg for now until Q&A. And Greg, you get to take a break. And up comes Tim. Hey, Tim.
How are you?
I'm good. You doing all right?
I'm doing just fine.
All right. And just so everyone knows, we didn't coordinate T-shirts. They are not the same T-shirt. We didn't do any of that on purpose. This is completely by accident. And then, so Tim's going to talk about operators for operations, which is going to probably chime well for people both in ops and DevOps and dev roles, so you understand all the sides of where this comes from. So Tim, I'm going to put you up, and it's your turn.
Perfect. Thanks, Aaron. So I'm going to do a bit of a talk track on operators for operations, specifically from the lens of the Ansible operator for Kubernetes, and kind of talk through kind of the concepts of it very briefly, and then do a demonstration on sort of building and running an Ansible operator and showing some of the code and that sort of stuff and kind of what it does and how to kind of extend that. And then kind of similar to Greg, the code for this will be available afterwards as well. So once we wrap up here, I'll get a push into our community events repo, and you'll be able to grab the sample operator that we have in this presentation. So a little bit of a brief about me. My focus at Arctiq is really around microservices and all things microservices, pipeline, and workflows. And I kind of like the all things automation. I call myself a lazy admin in that I like to automate everything. So the more I can automate, the better, which obviously makes Ansible a valuable tool in that toolkit. So a bit of a theme for this particular part of the talk track is really, don't I need to be a developer to make Kubernetes do things? And sort of there's a bit of a discussion to be had, around Kubernetes in general of, is it a platform? Is it a framework? Is it an API or a series of APIs? I kind of look at it as kind of all things. I mean, it's part platform, but it's a lot of framework as well. And, the operator SDK framework really fits within that. And the focus for this talk track is really around leveraging the Ansible operator, which is a flavor of the operator SDK, or a flavor of operator that the SDK helps you roll out, to kind of do things in Kubernetes and extend things with very little development knowledge. Essentially, some base Ansible skill set and an idea, and then effectively you've got an Ansible operator. And essentially, the idea is to kind of leverage the framework to kind of build out the scaffolding and build out the initial framework for you, so you don't have to go and do that. So it makes it very, very easy to consume. From a technical perspective, there are 3 flavors, official flavors of the operator SDK. One is the Ansible operator, which we'll talk about today, and then also the Helm version of this and the Go version of this. So for those with a bit more of a development background and familiarity with Go, that might be the direction you head. The focus on this side is really, and why I kind of said, operators for operations is really, there might not be that development skill set in-house. There might not be that Go skill set in-house, as an example. But it doesn't mean it has to stop there. If there's something that you want, your Kubernetes platform to do that it doesn't do today, Ansible makes a great option to kind of, get the functionality you want out of it without having to know Go or dive into the Helm operator. So the Ansible operator itself, it's built into the operator SDK. The operator SDK is essentially a utility to build out the scaffolding framework and help you build the images you need, help you deploy the operator to your clusters, that sort of stuff. Ultimately, it is a complete solution. So, and the operator SDK has undergone some changes. So if you've previously leveraged or tried the SDK, it has changed. So version 1 is out now. It is something that's built on the cube builder style layout. So the whole layout and structure of it's changed for the better. It's much simpler to use, much simpler to develop and deploy, and essentially gives you a little bit more flexibility and control. So customize is used heavily throughout the deployment method, that sort of stuff. Overall, it's an Ansible-based Kubernetes pod, a series of 2 containers that run playbooks and roles that effectively react to changes in any Kubernetes objects that you place in there. And so the idea behind the operator is you're defining a Kubernetes CRD, or custom resource definition, for whatever you want. And the Ansible playbook, or the Ansible container that runs as a part of this operator, is designed to listen for those changes. It watches for those changes to those custom resources. And as new ones are added or changed or removed, your Ansible playbooks or roles can then be keyed up to run something, to do some measure of work. And I'll walk through kind of the demo that I'm going to do and kind of the use case behind it. And some of that stuff will become a little bit more clear as well. The nice thing about this whole thing is it leverages the native authentication and native user and service account tokens in Kubernetes. So in terms of restricting or enabling the operator to do what it needs to do in cluster, or even perhaps other clusters, all of that leverages standard Kubernetes RBAC. So, familiarity with Kubernetes is great. From an operations standpoint, RBAC kind of fits within that structure. So it kind of makes sense to tie it all together that way. The operator itself can be deployed in either a cluster or namespace scoped option. So the one we're going to do today specifically is a cluster scoped operator. So we're going to have it listen for those custom resources in multiple namespaces, and more appropriately, we're also going to have it build things in other namespaces across the cluster. The idea of extending this even further is this next point around orchestrating resources outside the cluster. At the end of the day, the trigger point for the Ansible run is really the custom resource. So it's not an operator saying, Ansible playbook, pointing it at a playbook to run the actual playbook run. It is a custom resource that triggers it. But at the end of the day, it's an Ansible playbook. So anything you can do with Ansible, you can do with inside of an operator. So I've seen use cases within this where an Ansible operator might go orchestrate outside DNS resources, other external APIs. We've had some integration points with things like HashiCorp Vault as an example. So pretty much, anything you can kind of dream up, anything that Ansible can orchestrate today, which I can attest to so far is pretty well everything that I've run into, you can do this as a part of an operator. The last point here is and this has gotten better in the new experience. So the version 1 experience of Operator SDK is the local Ansible runner runs really, really well now. And the idea is you don't necessarily have to go through the process of building and pushing your Docker image every time you're changing your playbook logic. You can go and test this externally. And even when I was building this demo here, I actually didn't build a Docker image until I knew the thing worked. So I wasn't doing any build and push operations, nothing. I was using strictly just the local runner, which uses my local kube authentication to log into the cluster and get access and effectively run the playbook locally on my machine. So it's a nice little function to be able to kind of streamline development, and it's a familiarity thing too. So it looks and kind of feels like normal Ansible. Nothing really changes in terms of the actual layout of the playbooks or anything like that. It's just how it's triggered. And I should mention before I jump into the next sort of piece here, a lot of the questions come from kind of how do the pieces kind of work together. And I'm going to show that in the demo, but the idea here is as you apply a custom resource or change a custom resource, those custom resources end up in your playbook run as extra vars. So it's very, very similar operation to just doing an Ansible playbook -- extra vars, passing it a file or a series of extra vars. So anything that you place inside of that custom resource can then be consumed by your playbook as a set of variables. So very, very easy to work with. You don't really have to dive super deep into the inner workings of how the operator works. Effectively, as long as you give it the right permissions to do things inside of the cluster or outside of the cluster to any external resources, like you would with any Ansible playbook, you're pretty well golden. So I documented here a few steps to get started and kind of wanted to talk through these before I run the demo. But the idea is obviously the starting point is to get yourself the SDK. The simplest way is through GitHub. Install the SDK. It's a binary. Make a local directory to start building out your operator. So effectively, once you've got the SDK, just make sure you've got a directory to place your files that you're going to build out as a part of the operator, preferably a Git repo of some sort. A couple of quick commands to get started, and I'll kind of explain them. One is the init command, which basically initializes the initial structure. So building out all the folder structure and everything else that's required for your operator. We're specifying that we're using the Ansible plugin, so this is going to be an Ansible-based operator. And then we're specifying a domain, which can be anything. I chose Arctiq.ca. Effectively, it can be anything. What this ties into is how the API is represented in Kubernetes. And you'll see that as I show some of the custom resource definitions and all that sort of stuff as a part of the demo. The next piece here is around creating the API. So this is effectively you creating the custom resources that you're going to watch in the cluster. And so we just issue the create API command. We give it a group, and that group is going to get tacked onto our domain. So our API spec is going to look like operations.arctiq.ca. I could have named it anything. I named it operations. Doesn't really matter. It's fairly arbitrary. We specify the version v1 alpha 1, which is again for the API definition. The kind is what we're going to specify the custom resource to be, what type it's going to be. So similar to any other Kubernetes object, it's going to have a kind, whether it's a pod, a service, a deployment, whatever that object is, it's got a kind. So what we're doing here is we're telling our operator what kind it's going to watch for and what it's going to build in terms of custom resource definitions. And this SDK lays all this out for us, so we don't have to do any of this work. And then -- generate role on the end here builds out all the role framework for us to do the Ansible work we need. So pretty well in a couple of quick steps, we've got an initial framework, and I'll show you kind of what that directory structure looks like and all that, but it's pretty straightforward. The next series of steps are really around installing the custom resource definitions. So effectively allowing Kubernetes to understand your new object type of, in our case, app team. And maybe this is a good bit of a stopping point to set the stage a little bit for the demo. What I'm going to demonstrate is a use case here where you've got a requirement in Kubernetes to onboard application teams. And you want to onboard those application teams in the exact same way each time. You want them to have the same resources available to them, the same users that interact with them, separate them out into separate namespaces, all that sort of stuff. All of that would typically be fairly manual work inside of a Kubernetes environment. What this definition here is, I'm going to define a new custom resource called an app team. And then anybody that has access to the cluster and the RBAC capabilities to manage this kind now called app team can issue a custom resource to the cluster to define things that would define an app team. And our playbook is going to go and lay out some scaffolding in Kubernetes to support those app teams. And in specific, when we get into the demo, an app team definition is going to spin up exactly 3 namespaces. It's going to spin up a dev namespace, a QA namespace, and a prod namespace. And then it's going to generate all the RBAC configurations for each of those based off of what's placed in this app team definition. And then it's going to go and create network policies to segment those namespaces. And in particular, we're going to make sure those namespaces can only talk, or pods within those namespaces can only talk within the namespace with each other. They can't talk to anything else. Nothing else can talk to them. And I'll show you kind of some of the stuff that I've got in the playbook logic to build all this stuff out. Once we've got the CRDs in the cluster, effectively, we now go into development. So we're writing our playbooks or roles or a combination thereof according to what you want to do based off of the custom resource that's placed in. So the workflow is a user defines an app team spec. They issue that app team spec to Kubernetes. The Ansible playbook then uses that information as extra vars and goes and does some stuff. And I'll show you all of the stuff. The very last steps here are really the build and push. So once you're kind of settled on the playbook logic, everything is kind of working, then effectively you're going to go do a build and a push operation. And the SDK makes this, fairly straightforward now with a make file. So this is a little bit different too with the version 1 of the framework. So we're going to do a make Docker build and a Docker push, specifying the image. So where are we going to place this? What's the registry I have access to? All that sort of stuff. And then we're going to go and deploy. So effectively go and deploy the operator to our cluster. The nice thing about this makefile methodology is this wraps customize in here and everything. So it's going to customize your operator with the image that you've now built. And I'll show you the Docker file. It's pretty straightforward. Not generally something you need to customize. The idea is anytime you change your playbook logic or role logic or the logic around what types of objects it's going to watch for in Kubernetes, then you're going to do a build and push operation and redeploy the operator. And then the last step is really just add a custom resource of some sort and watch the operator go. So I'm going to dive into the demo. And again, kind of like what Aaron was saying, if there are questions along the way, feel free to add them to the comment section in YouTube. Otherwise, we will have the Q&A at the end as well. So I've gone ahead and deployed the operator mostly because I didn't want to necessarily go through the process here of doing the deploy live, but it is running. So we've got the onboard operator, which I've called it based off of how I built this out with the SDK. It builds it out into a namespace, so onboard operator system namespace inside of this OpenShift cluster that I have online here. And the idea is I want to now leverage this operator to build out the scaffolding and framework for application teams inside of my cluster. So what I'll do first is kind of walk you through some of the framework and kind of how the development of the Ansible playbook would work and all that sort of stuff. show you a little bit of kind of what's happening behind the scenes, and then run a demo of actually adding some app teams to our Kubernetes cluster. And I'll start here with just showing some base stuff. It's a base OpenShift cluster. There's nothing special in terms of how it's been deployed. It's a version 4 cluster, so there's a ton of stuff that's deployed as a part of the system and a bunch of functionality there, but no application namespaces. The only extra namespace that's been added to this is for our actual operator. And so the idea is starting off with sort of a fresh cluster. I mean, our use case here could be applied to any cluster, doesn't really matter, but we just happen to be a fresh one in this case. So I'm going to show you some of the code here. So one of the things that I wanted to show you is the actual structure itself. So maybe I'll just stretch this over here and just walk through a little bit of how this gets laid out. And I will close up some of these just to make this a little bit cleaner. So the idea is the scaffolding or the framework, when you do an operator SDK init, give it inside of a folder, give it a name, all that sort of stuff. It builds out all this file and folder structure underneath this onboard operator folder. And the idea is it lays in a Docker file. The Docker file, like I mentioned, is pretty straightforward. All it's doing is leveraging a base image here, copying in any requirements in terms of Galaxy roles, any of that sort of stuff. Aaron made mention at the start of the presentation around the focus on Ansible collections. The new version of the operator leverages Ansible collections. So we're using that inside of the playbook logic as well. We're copying a watches file. I'll explain that one in a second. We're copying all of our roles over and our playbooks over, and that's it. That's all the Docker image does. And so that's where I was saying normally to extend functionality, you normally don't need to modify this Docker file to change how Ansible is going to run. Normally what you're doing is adding new functionality to roles or playbooks to change the automation in some way, shape, or form. The make file gets laid out by the SDK, so we don't really have to modify anything here, but this is something that the new version of the SDK builds out for you. Any requirements we need can be built into here. So we can see, again, the use of collections to bring in the Kubernetes modules that we need for our particular use case. So this is where you could go and extend this to other things. So if you needed to add other modules, some custom modules, that sort of stuff, this is kind of where you start to extend that. And I made mention to this watches file. This watches file gets built out by the operator SDK. It gets built out with a very base set of information. In specific, it gets built out with the first 6 lines here using this create API command. And all this is doing is now telling the operator, because this watches file gets copied to the Docker image, so when the operator runs, it is aware and knows how to interact with this watches file. This watches file tells the operator exactly what to watch for, so what type of custom resources to watch for, and then some other parameters that we might want to customize. In particular, I added a couple of things here. Watch dependent resources effectively allows the Kubernetes operator, or this Ansible operator, to also watch the resources that it creates as a part of that custom resource. So in our case, we're going to build out 3 namespaces. We're going to build out RBAC policies in the form of role bindings, and we're going to build out network policies. Watch dependent resources allows us to keep control of things, because this is also going to be on a reconcile loop. And so what that means is this Ansible operator is going to constantly run on a loop as things change. So effectively, by doing this dependent resources call here and saying this is true, if those objects are created and managed by this operator, so let's take that network policy object as an example. If somebody else goes in and changes that object, so gives a less restrictive set of permissions on the role binding, like to elevate to cluster admin, let's call it, or something like that, or tries to tear down the network policy. Setting this will now allow the operator to go rewrite that again. So on the next playbook run, it'll actually trigger a playbook run when a dependent resource gets changed. And the playbook will run, and because Ansible is declarative, it'll go and make it so. So this is our way of kind of keeping things in check and controlled through the operator framework versus having this fight between operators making changes versus what the actual operator is doing. The next set of things here is we're also going to watch for cluster scoped resources. In our case, we want to manage namespaces, so we need to watch for cluster scoped resources. And the last little bit here is about finalizers. So the one thing that's kind of neat here is I want to be able to tear down the namespaces when a custom resource is deleted. And normally that's not possible with a cluster scoped resource or a resource that's in a different namespace. And because our use case here is going to expand upon multiple namespaces, we need to customize this with a finalizer. And what we do here is we pass this a set of variables. And so the idea is the finalizer is something we can say when you remove a custom resource in Kubernetes, go and run its playbook again. In our case, we're going to run the same playbook or same role again, but we're going to run it with a different set of variables. In our case, we're going to run it with the state variable set to absent. And that's what's going to get passed into our playbook or role run. And then I'll just detail a little bit about how the playbook gets structured and then do a quick demo and then open things up for questions. So like I said, we are going to do things with a role. So our watches file here details that when anything changes in a custom resource of kind app team, trigger an Ansible playbook run that targets specifically this role called app team. And when we go and develop, this is going to look very familiar for anybody that's done any Ansible work. This structure looks very much like any other Ansible role. So any other things that you want to do take shape here. So any Jinja templates can be placed in here. Any static files can be placed in here. And in this example, I used a combination of the two of them. Any role defaults can be defined here. And then, of course, my tasks. Handlers can be used, any of that sort of stuff. We're not using handlers in this particular use case, but anything here applies. And so one of the things that I wanted to show is we set some role defaults. So the environments I care about for the app team specification here are a dev environment, a QA environment, and a prod environment. And then I'm going to define a set of network policy files. And then I'm going to define a set of RBAC files. And the idea here is we're going to use these variables in our playbook or role logic to make sure that that we can orchestrate things the way we want to in a clean fashion. So we're going to use all the same best practices we would use in Ansible in terms of using loops where we can, Jinja templates where we can or need to, and that sort of stuff. We're going to do that in this example as well. And the main role logic is pretty straightforward. We're actually only making calls to 3 modules, nothing more, nothing less. And so very, very simple use case. Anytime this playbook is run, which again is going to be triggered on the creation of a custom resource called app team, we're going to deploy the namespaces. And we're going to loop over all of the environments. And the interesting part about this is we're going to name these namespaces based off of the Ansible operator metadata name. So this is going to come from the custom resource. So I'm going to add an app team, call it app team ABC. That's going to be the name of the custom resource. So when this playbook runs, we're able to pull that in, again, as extra var data to be able to use this in our playbook logic. And so effectively, we're going to spin up 3 namespaces based off of the name dash the item here, because we're on a loop. So it's going to pick each environment here. And then we're going to set a state. So we're going to say the state is based off of the state variable. We're going to default it to present. This allows us to use that finalizer that I showed briefly there. Where when we want to tear down the resources, we want to pass an absent state. So this allows us to leverage the same playbook. We could define a finalizer that uses a different playbook or different role. In this case, wanted to keep it pretty straightforward. And then so we have deploy network policy. So the idea behind this is we're now going to go, once we've got the namespaces in place, we're going to go define the network policies. And we're going to do this, again, very similar fashion, except we're going to do a nested loop. And the idea here is that nested loop is going to give us the ability to loop over all 3 environments, but also all of the network policy files that are relevant here. Excuse me. And the last one we're going to do is we're going to go and deploy the RBAC items that we need. I named this incorrectly because we're going to deploy all of the RBAC policies we need, again, based off of a nested loop here. So we're going to go define this based off of the environments as well as the RBAC files. In this case, we're going to do those based off of a template. And so this is the last sort of key component here, is within these Ansible modules, we're using, inside of the definition, we're doing a lookup plugin. And the lookup plugin allows us to keep those files separated out in the folder structure rather than defining them inline here. And then gives us also the added benefit of being able to use Jinja to template these out. And where this becomes important is specifically around the RBAC stuff. So with RBAC, we're going to go and define 3 namespaces. With a role binding, I need to also specify the target that we want for those groups or users or whatever in terms of the RBAC. So it has to include a namespace. So leveraging Jinja, we can then do, as an example, if I take a look at this Jinja template for the RBAC admin policy, this looks like any other standard role binding in Kubernetes. The difference is we're going to go and use Jinja to loop over the list of admin groups that a user might define in an app team that we specify. And so effectively, this is going to allow us to go and build out any number of admin groups that we want. These other ones, edit and view, follow suit. They look exactly the same. The difference is we're targeting a different role. And actually, in my case, I think I messed up, which is fine. So we'll just change this up because we're doing live demo. So we recognize mistakes in live demo. So I'm going to switch these over. So now each of these 3 policy definitions would be changed up here. So we'd have an admin, an edit, and a view policy here. And so, like I said, each one of these can go and spin up any number of groups that would be part of this policy based off of this Jinja loop that will go and loop over those and define each of these out. And again, same for edit groups, same for view groups. And that, in a very, very quick blast of information, is how the Ansible playbook stuff gets kind of put together. There's a bunch of stuff around the actual operator itself in terms of the configuration. So this is how the operator itself gets installed and defined, including the custom resources, that sort of stuff. I think I'll hold some of that for Q&A and also something that can be consumed later. Like I said, all this code is going to be in our community events repo after this presentation, so feel free to consume as needed and ask questions. In the meantime, what I want to do is show you kind of how these particular resources get laid into the cluster. So like I showed you, we have nothing really in the cluster. We've got no app namespaces in here, nothing. And the use case really is I want to go scaffold out basically application teams. And so we'll have a look at the application teams. We've loaded them in samples here. And the idea is we have 3 custom resources I've defined here. App 123, app ABC, app XYZ, and mostly because I am not feeling super creative today. So they are pretty boring names. But the idea is I create an app team definition here called app team 123. And you notice really the differences here between this and any other Kubernetes object is the API version and the kind being app team. And the idea here is we're going to give it a name, app team 123, and then we're going to specify the list of admin groups, edit groups, and view groups that we want to add to our RBAC policies. So this is the example of basically specifying in a custom resource any set of things we want to specify for our use case, and then have our Ansible playbook use these. In our case, it's our Jinja template that's going to use the admin groups, edit groups, and view groups to spin up those templates and basically template out the RBAC policies accordingly. And so we're going to go through a quick demo here to do app team 123. And in this folder for demo here, I've got each of these 3 custom policies here. And in another window over here, I've got the actual Ansible operator logs tailing out. So we can kind of see, this job actually getting kicked off. And so right now, nothing's happening. So this container is effectively staying dormant. It's got no work to do. And it's kind of just waiting and watching. So we can see some messages here around watching, what things it's going to watch for, environment variables that could be set but aren't set based off of our use case, and kind of starting up of all the services. So we're ready to go. And as long as everything behaves correctly, we should run into no issues. And so in our case, and again, maybe I'll just show it here, operations, and we're going to apply this custom resource for app team 123. And so we'll do an OC create -F, and we're going to do the 123 resource, and we're going to apply the custom resource. because our Ansible playbook is now set to watch on this, we're now going to trigger, and that is misbehaving. Let's do it this way again. So now we're seeing our playbook actually run. So we're seeing a bunch of information that we would normally see in an Ansible playbook run. A little bit more verbosity around the OpenShift and Kubernetes modules, but effectively the same sort of output. An interesting use case might be kind of pairing up what Greg presented previously around Slack notifications with what the operator is doing. Because effectively, again, this is just Ansible underneath the hood, so we could add anything we wanted to it. The important part about this is we can see the final results of a playbook run. And in effect, we actually end up running the playbook a couple of times here based off of how we've got the loop set up. But the more important part is when we go OC get namespaces, we're going to see we now have 3 new namespaces, appteam123-dev-prod and -QA. And then if we do an OC get network policy, and let's just do it across all namespaces, we're going to see a couple of things. We've got the playbook logic set to have network policies specified for only 2 of the 3 namespaces. And the idea here is the use case might be that your dev namespace, you don't care to segment it. You might want to leave it open. Troubleshoot things from an app level, not necessarily lock things in, whereas you might want to do that in QA and prod as an example. Again, a somewhat arbitrary use case, but somewhat also applicable to anything we've seen out there. And then we see each one of these namespaces in prod and QA that are locked down have exactly 3 network policies. One to allow OpenShift ingress controller access to the pods in the namespace, so we can get access from the outside, so for running a web service or whatever the case is, from OpenShift monitoring, as well as allow from same namespace. So those 3 network policies together basically lock those namespaces from a traffic perspective within each other. And now we see that we've got some consistency there. We've got all of the namespaces configured accordingly. And an operator would be no good unless we were using this to solve for a scale challenge. So now we want to onboard a new application team. And we want to onboard the app ABC team. So now we're going to go and we're going to do the same sort of workflow here, but now for the app ABC team. Now we've created it. Similar process, the Ansible playbook is going to run, and it's going to go do all the loops that we specified to go build out the Kubernetes objects that we've told it to do in cluster. So inside of our OpenShift environment, now we're going to have a second app team deployed with the exact same set of restrictions and functionality as the previous app team, with the difference in the RBAC policies, and I'll show you those next. Now we have a look at the network policies. Now we have network policies on the app123 namespaces as well as the ABC namespaces. And again, we've skipped dev. We've done that purposely in the playbook logic. And just to kind of show how Ansible this is, if that's a way to term that, when we look at the tasks here, we can see that in line 16, this is exactly where we're saying, don't deploy the network policy modules for the dev environment particular. There's lots of ways we could extend this. We could customize this in the custom resource and pass this in as a variable. For the demo use case, I just kept it fairly straightforward and just said, base this off of the dev environment not needing the same namespace control. And so if we go and create the last one, just because we might as well, we're going to onboard the last team. So now we're going to have 3 app teams onboarded. And again, we can kind of see that status. And I think, again, this might be a kind of a cool use case to pair up with what Greg had done around the Slack notifications. So we'd know out of band through chat ops that everything was scaffolded out correctly. That being said, this is a pretty simple use case, so it generally doesn't take too long to run through this playbook. And we're already done, and we've got everything deployed here. So let's do, again, the network policy view and have a look. Now we've got 3 app teams onboarded. Each of those app teams has network policies built out according to their requirements. And what I want to show you is switching over to one of these application namespaces. So app team 123 prod namespace. Let's get the role bindings. And so in particular, what we're concerned with is these 3 role bindings that we had Ansible create for us based off of what we had in the custom resource specification. So the one I want to inspect in particular is OC describe. And so we see that the operator did what we told it to do. It built out a role here that gave us edit access because I messed up those custom resource. So I changed them afterwards to admin. But the idea here is it looped over our admin groups. So we can see admin 123 and admin 2123. And those are exactly in line with what we had asked it to do in terms of the app 123 custom resource definition. So all we had to do based off of this use case was define an app team spec, tell inside the app team spec what groups I want for admin groups, edit groups, and view groups, and our Ansible playbook goes and takes care of all the logic to complete the work. And the last little piece I will show you is the idea of using the finalizers to tear all of this down. So we've got role bindings, we've got network policies, we've got the namespaces themselves. So now when I go get the namespace, we can see we've got 3 namespaces set up for each of our app teams in our OpenShift cluster. And now we want to go and tear all these down. Normally, I'd have to go, maybe I could delete the namespace, although with most things now in Kubernetes and custom resources and finalizers, just deleting a namespace can be a pretty interesting adventure. Normally, you've got to tear down all the things within the namespace first. And so one of the things that we're going to do is then go and just, instead of deleting namespaces, we're going to go and delete the actual custom resources. And actually, maybe just before I do that, I'm going to show you a little bit of a live demo here on that watching dependent resources. So we are in the app team 123 prod namespace. And I had shown you this idea of getting the role bindings, and we can see our role bindings that we had created previously, or we had the operator do for us. If I do delete app team admin. This is true live demo because I did not test this. So hopefully this actually works as designed. But the idea is this should lay in on the next playbook run everything that's in there. And it is not doing it. So I might have messed up something. But the idea is that dependent resource should now be dropping in on the next playbook run. I probably missed something in the watches file. So I'll clear that up when we put it into community events. In the meantime, let's do delete -f on all of those resources. Oops. And deleting. Oh, that's why. Okay, OC project. Get project. So one of the things is these custom resources also exist within the namespace with the operator here based off of how I laid this out. So we're going to switch back over. And we can just do this through a cube delete instead. So if we do get app team. So this is our custom resource spec. So again, kind of this idea of this being a Kubernetes native object now. And this is being a bit slow for me right now, but so idea here is this is the custom resource that's been applied to the cluster. One of the things I did want to show before we go and delete these is this idea of the status reporting. So Ansible's reporting the status back to the custom resource as well. So we can see right at the custom resource level that we've got success here. And this is where I was talking about we're not getting the dependent resources. It's sitting waiting for the next reconciliation. So likely something to tweak there. But what I want to do is go and delete all the app teams. And by deleting the app teams, our finalizer playbook starts to kick off. That's going to go and start to destroy all of the resources that were set up by the operator. So all the namespaces, RBAC policies, network policy, everything that we've specified to build out as a part of the operator is now going to be torn down. But that's just simply removing the custom resource. So we don't have to go and clean things up manually. We don't have to go and figure out if we missed something or something along those lines. So now when we go and have a look at app team resources, there are none. And we do a get namespaces, and we will see that we have exactly 0 of those application namespaces on board. Actually, I'll show you network policy. And so we see we've got no network policies. So that's all I had for a demo. Like I said, I'm going to push the latest changes here into community events after we wrap up here. So feel free to consume this pretty quick example of an operator. Most of the idea here was to show that we can use just straight up Ansible to orchestrate things in Kubernetes in a pretty slick and sort of streamlined fashion without really needing to leave Kubernetes in terms of how we interact with it. So everything that I did here is with OC commands to our OpenShift cluster. Nothing special. Everything kind of works as a Kubernetes native resource. It just happens to be Ansible underneath the hood that's orchestrating all the work. So the use cases are endless. To me, it's come up with an idea and extend it from there. As long as you can write it into a playbook, it's something you can certainly orchestrate. I'll kick it back over to Aaron.
Thanks, Tim. That was great. This is definitely a topic that's probably going to become much more popular, over time. We've already seen it start to get a little bit popular, and automating with Ansible and what everyone calls, the complexity thing that is Kubernetes is definitely appealing. Hey, Greg, brought you back. So now that we've gone through both presentations, let's cover off a little bit of Q&A, and then you can feel free, guys, to even just mention anything you might have missed. It's a really good set of topics because it's true what Tim was saying, that you could probably merge the concept of what Greg was doing with operators in your OpenShift or Kubernetes clusters and get some interesting talk back and forth with Slack while seeing what your operators are doing in Ansible. And it's a really nice, intermesh and integration of several different tools that we use pretty often. I do have a couple ones that came in, Greg. So the question is, does the plugin that you wrote, does that work equally as well with AWX or Tower as with Ansible open source?
Yeah, I would assume so, because the AWS. So this is really plug into the Ansible runner. So I don't see why it will not work. Yeah.
Okay, fair enough. Tim, I noticed the Docker file in there. So does the SDK work equally as well with Podman or Builda?
Yep, yeah, it would work with anything in terms of a builder. The actual image that I built, I think it was either built. No, it was a Kaneko based builder. So basically, it can build with anything really. It's a Docker file spec. So as long as what's in there will work with whatever builder, you should be fine. That being said, that Docker file, like I showed, is pretty straightforward. It's only a few lines. It's mostly about copying in the playbooks and roles. Everything else is built into the base image that's hosted at a Quay.
And do people have to use Quay for that, or can they use any registry?
Use any registry you want. You just have to stage it, right? So the one that's shipped from the community as a part of the version 1 of the SDK comes out of Quay. So, if it was something you wanted to stage into an on-prem registry, then that could be done as well. No issue there. It could be any registry really. doesn't matter too much.
Very good. Greg, with because I don't know if you pointed it out as much as maybe it deserves, I think, but given that you wrote that plugin, what did you do differently in your version of the plugin than the one that you already found open in the community? Did you do anything different that sticks out?
So it's simplified. So the overwriting just one single method is different. Also, I've updated the version of the Slack module to the formatting. So the previous formatting was different, using a table and not, maybe more relevant to an older version. So this one is more up to date.
Okay, that's great. So I take it that when you put that in the community code repo, you're open to having PRs from the community?
Yeah, absolutely.
All right, that's good. Tim, I mean, given that you went on this little journey for this demo, are there any highlights that people might want to look for when writing operators for Kubernetes vanilla versus OpenShift, or should it be all fair game?
I think it's all fair game. The only thing you might end up with is orchestrating some of the OpenShift specifics, right? Like security constraints and that sort of stuff that might be something that needs to get changed or modified in some way. For the most part, the operator deploys with standard RBAC policies. Doesn't really need a whole lot of privileges in terms of it doesn't need to talk to a host or anything like that. So it fits very well unmodified inside of an OpenShift cluster. So the things to really watch for, and I did this in the version of code that will be made available publicly, is I needed to change the RBAC that the operator ships with. So the things that I was orchestrating in the cluster, namespaces, role bindings, and network policy, aren't something that are part of the standard role that gets shipped with the operator framework. So there are some customizations required when you want to orchestrate certain things. And that's mostly because the operator ships the base set of things that it can orchestrate, but it doesn't, try to expand beyond that, especially when we're trying to orchestrate things outside of a namespace or cluster scoped objects like namespaces themselves. So there's a few things that you kind of need to tweak and tune to kind of get it to work the way you need it to. Most of that falls under standard sort of operating principles for, either OpenShift or Kubernetes in general. So.
Okay, great. Thanks. There weren't too many others that came in, but if there's anything else that you guys want to call out for the stuff that you were talking about, feel free. And then I think we're going to wrap up.
Yeah, the only thing on my side is it's really about coming up with the idea, coming up with the use case, right? So I think about when I look to go and I've done a few of the Ansible operator initiatives, and the reality of it is it starts from the use case. Starts from a requirement. It's I wish that Kubernetes did this. I wish that when somebody added a new deployment that it would also go and talk to my Infoblocks cluster, as an example, and go plumb DNS records for me in Infoblocks. That kind of stuff, that starts to sound like really, really solid use cases to extend OpenShift to go orchestrate other things. And kind of the whole vein of the talk track is I don't need to be a developer to go do that. And that's powerful for me in an operations capacity, to be able to extend the platform that I am going to support, build, and extend without necessarily having to figure out how to do this in Go. Right? There might be a better path, right? Like Go might run quicker, might be more efficient, might be able to do more things and that sort of stuff. So it's not to say that there's not merit in going and building those. It's just, to me, especially with a good solid background in Ansible, it's a very, very easy way to extend OpenShift and Kubernetes in general.
I very much look forward to making custom resources that Ansible can create, and I'll call them cookies, and I can say OC get cookies, and then everyone's happy to see how many cookies they can replicate in a Kubernetes cluster. And maybe for Ron on the chat, we could make them called custom resources called peach pies. Looking forward to doing that, Ron.
We can make them anything we want.
Yeah, custom resources. That's it. Anything else from you, Greg?
Yes, no, nothing special. So I was really happy to learn about those operators. So thank you, Tim, for the presentation.
All right, looking good. So just to finish this off, no matter how many times I see that meme, I just can't resist the amount of enthusiasm that he shows, you know, in his face about automating all the things. If you like any of the stuff that you've seen in terms of the automation, we have lots of stuff in our GitHub repo. We have even more stuff in our blog at arctiq.ca and at ansible.com, in case you've not heard of Ansible by some crazy feat of luck by now and you want to go read about it. So that is it for today. Thanks everyone for joining us. August 2020 Ansible Toronto Meetup. Again, it's virtual, and we'll see you the next time that we do it. Bye-bye.
Bye, guys.
Bye.